Good morning, or good afternoon, or good evening, everyone. Welcome to this second section of the day. I am Valentina Lenarduzzi from Aluit University. And today we will have 4 papers in this session. 1 journal first paper, 2 technical papers, and at the end, 1 emerging results and vision paper. So the first paper will be presented by Andreas Vogelsang. And okay, Andreas, are you here? Yeah. And the title of the paper is Views on Quality Requirements in Academia and Practice, Commonality Differences and Context-Dependent Gray Areas. So, Andreas, the stage is yours. Remember for the audience to provide your question in our YouTube channel. Thank you.
Okay, thank you very much. Welcome to my talk. This is a journal first presentation of an article that we have originally published in IST in 2020, and this is joint work with Jonas Eckhardt, who's now working in industry at Tableau Software, Daniel Mendez from Karlskrona and Fortis in Munich, and Moritz Berger from the University of Bonn. And in this paper, or in this article, we did some research on the perception of quality requirements and challenges related to that in practice, and we compared this to perceptions that we usually find in academic papers, for example. So this is actually a continuation of our work that we did on quality requirements and their perception in practice. So a bit of a background. So we started in 2016 with an ICSI paper where we analyzed requirement specifications from industry, and we analyzed whether the distinction between functional requirements and quality requirements, or quality requirements as they are sometimes also called non-functional requirements, how they appear in industrial specifications, and also how clearly the differentiation is. And we classified the requirements that we found in these specifications with respect to several taxonomies, and we found out that actually this differentiation in industrial specifications is not really clear. So we found a lot of evidence that sometimes functional requirements are actually described as non-functional requirements or labeled as non-functional requirements, and also the other way around. Then we had a follow-up paper at Profess in 2016 where we surveyed a large number of practitioners, because we were interested in, does it really make a difference, this differentiation between different types of requirements? Because, you know, we teach that in universities, and of course it's we know that you can have these different type of requirements, but does it really make a difference? And we found out that this distinction actually makes a difference. So the fact that you have documented types in specific sections, for example, of a requirement specification, that actually makes a difference in the way how these requirements are handled. So in the article at hand, we were then interested how do practitioners perceive certain statements that we often find in academic literature, and how do they think how do they think they are true, or how true they are, let's say, in their experience. So for example, some general statements like the application domain strongly influences the relevance of quality requirements. This is something that we found quite regularly in academic papers. Or in elicitation, the focus is usually on functional requirements and not so much on quality requirements. Also a statement that we found in a good number of sources. Interestingly, we also found statements like, for example, QRs are often not documented, where we found papers that stated that this statement is true, but we also found evidence or papers where this was, let's say, stated the other way around. So even in academic papers, there is some, let's say, disagreement or different viewpoints on these kind of statements. Another example, in testing, most quality requirements types are difficult to test properly. That seems also to be a very common thing to say in academic papers. In management, for example, we found statements like QRs are often not sufficiently prioritized. There we also found papers that said yes, this is true, and also papers that found evidence against that. So we were interested. So we came up with a list of 21 of these statements about quality requirements. We were interested in the question: do practitioners agree with these statements that emerge from academic research? So we did an online survey, again, with practitioners. We received 109 complete answers. And for each of these 21 statements about quality requirements, we asked the practitioners, how strongly do you agree with the following statements? The participants were able to state their agreement on a 5-point Likert scale. And afterwards, so besides presenting the results of these answers, we also applied a statistical regression model to analyze the impact of certain context factors. So the participants also stated in which type of company they were working, how much of experience they have, what is their role, what is their domain, and so on. So, and we used a statistical regression model to analyze the impact of these factors onto the agreement towards the statements. So let's have a look into the results. First of all, let's have a look at the demographics, which is, by the way, also a subset of the context factors that we elicited. So you could see we had a broad variety of different people with different roles, requirements engineers, of course, project managers, development architects. We had a good overview of industrial sectors from different domains, different team sizes, also different company sizes. Also a good mix in terms of the process paradigm. So you can see at the bottom left, there were people who mainly work plan-driven, mixed, or agile, and also a good distribution in terms of geographical distribution. Okay, so let's have a look at the general agreement or disagreement with our statements. So on the right-hand side, you can see for all of the 21 claims, so these are the rows, what is the general level of agreement or disagreement. So the different bars here indicate the different levels of the Likert scale. So on the left side, that's more agreement. On the right side, there's more disagreement. And you can see there were clearly a good number of statements where practitioners also agreed with the perception. So, for example, strong agreement with the statement that the application domain strongly influences the relevance of quality requirements. Software architects do not use a specific tool for QR management. And also in requirements elicitation, the focus is on functional requirements and not on quality requirements. But we also found some statements where there was definitely more disagreement, or let's say more disagreement than agreement. For example, that the statement that only few quality requirements deal with architectural aspects, or that functional requirements are often labeled as quality requirements. This was something that practitioners did not really agree with. And as well, that testing QRs is impossible, right? So secondly, we analyzed the different context factors, and we came up with this kind of visualization. So you see different plots here, and each plot corresponds to one specific context factor. So for example, the role here. And we draw, and so you see the purple dots here are the different roles that we had. And you see an arrow if we found a statistically significant impact of this role towards the agreement of a certain claim. If it's green, then it's a positive relationship, and if it's red, it's a negative. And the size of the arrow also indicates the effect size. So some interesting cases here, for example, that you can see is, for example, the claim or the statement T3 is most QR types are difficult to test properly. This is something that especially people from automotive, managers, and people who develop business information systems agreed to. On the other hand, people like more senior people and people from finance and non-distributed projects, they would say, or there was less agreement with that claim, for example, right? Which is interesting because that is actually now paves the way for additional research. So in order to visualize this a bit more, we also came up with this kind of chart. So in this chart, you see the different statements that we tested, and you see on the x-axis the mean agreement with the claim. On the y-axis, you see the consensus between the participants. So the larger the consensus was, the larger the consensus was, the more consensus was within the participants. And we then categorized the statements into 4 different classes. So the one on the upper right are basically commonalities. So there's a large agreement also in practice that these are true statements. We also had differences, clear differences, where practitioners clearly said that this is not true. But then maybe more interesting is the lower part, where you have statements with a strong agreement, but also with low consensus. So this would be something that would need follow-up studies, because it may be the case that these statements are not true in all of the circumstances, in all of the contexts, for example. Similar for statements with a low mean agreement but also low consensus. This could mean that these studies or these statements in these studies need more contextualization, because it may be the case that these statements were made in a very specific context. Okay, so to conclude my talk, this was just a very rough overview. If you're interested in the detailed results, please have a look at the paper. What I presented was our study on the agreement of practitioners with research statements on quality requirements, the influence of context factors on the agreement, and finally this map that shows need for contextualization and follow-up studies. So thank you very much for listening, and I'm happy to take questions now.
Okay, so thank you very much, Andreas, for your nice presentation. There are questions from the audience. Please formalize in the chat. Okay, I can start with one question that is my curiosity. When you presented the results comparing the disagreement and agreement, in the disagreement, you say that testing the quality requirements is impossible, and the functional requirements are labeled generally as quality requirements. Can you provide an example, or they completely disagree on the entire category, or they partially disagree with one of them, or more than one?
Yes, so the participants were asked to rate each of the statements individually, and this example of testing quality requirements is impossible. That's a statement that we found in one academic paper, and so the participants got to read the statement, and then a good number of them said, "No, I don't agree with that," which might be reasonable, because actually they think, okay, it's not completely impossible to test quality requirements, right? And likewise with the others. So that was the reason behind that, and that's the answer.
Okay, perfect. So thank you very much for your answer. There are question from the audience. No. So thank you very much, Andreas, for your nice presentation. And we can move to the... there is one question, since we have time, so provided by Alessio Ferrari. Thanks, Alessio, to be on time on this question. He said, nice study, Andreas. Did you ask about relevance of requirement types in relation to product success? I have the feeling that violated quality requirements are more critical, but would like to know more from you.
If I remember correctly, we did not test any statement on the relation between violation of quality requirements and project success. That would actually be an interesting statement to test as well, but we didn't ask for that specifically. So we the way how we came up with the statement candidates was that we looked through. It was not a completely systematic process, let's say. So we did not do a systematic literature study to find out all the statements about quality requirements, but we looked at a good portion of, or a good number of papers and extracted these statements from the papers. I need to double check how many papers we had in total, but you can also look that up in the article.
Okay, thank you very much. I hope that Alessio will be satisfied by your answer. Remember, Andreas, that there is other two questions, one provided by Nick and one from Marcos in YouTube channel. Please have a look. And thank you again very much for your presentation. We can move to the second presenter, that is Yang Luo. Okay. Yang, are you here? I cannot see you. I cannot see you, only hear you. No, I don't know if it, because, okay. Oh, we still not see you. Okay, now I can see you. Maybe you have a little bit problem with connection because you are blurry. Can you try to speak, please? Because otherwise we go to...
Me now? Still can.
Yes, now you are better. Okay, perfect. So this is the first technical paper of this section, will be presented by Yajing Luo, and the title of the paper is Characteristics and Challenge of Low Code Development, the Practitioner Perspective. So the stage is yours.
Okay. Hello everyone, I will give a presentation of paper. So first, let's talk about the background and the way of organization have emerged with the promise that organizations can hire business professionals with no code experience to build their applications and offer enterprises a more economical way to fulfill the market. The term low code was first introduced in 2014, which states that firms prefer to choose low code alternatives for fast can accelerate the development by 5 to 10 times. So we set the research goal to explore the characteristics and challenges of low-code development from the perspective of practitioners with 9 research questions. In particular, we explore the understanding, platforms, programming languages, implementation units, supporting technologies, types of applications, domains, benefits, and limitations and the challenges about low-code development. And for the methodology, in our work, we explored two popular online developer communities, Stack Overflow and Reddit. We used two low-code development-related terms to search the related posts in Stack Overflow, and we extracted 33 candidate posts. Meanwhile, we explored 3 low-code development-related subreddits from Reddit and collected 228 posts. Then we extracted data from these posts and applied the constant comparison method to analyze the descriptions, benefits, and limitations and the challenges of low-code development. For the rest of the research questions, we use descriptive statistics to analyze and present the results. And here comes to the study results. For research question 1, from the table, we can see that although there is no clear definition of low-code development, practitioners can use low-code and drag and drop to describe low-code development according to their understanding, showing that low-code companies and class of those platforms Communication units are perceptually more intuitive than code. Thus, users are not aware of the complexities with those where it's
Sorry to have interrupted the presentation, but as you can see, we have a problem with the connection with the presenter. So we will run the video at the end of the session as last one, so we can continue with the second paper if it is ready. So Arif, are you there? Yeah. Yes. So thank you very much, and sorry again for this inconvenience. We will have the third paper, so second technical paper of this session, presented by Arif Nurwidyantoro. Sorry if I don't pronounce correct your name. And the title of the paper is Toward the Human Value Dashboard for Software Development and Exploratory Study. Arif, the stage is yours.
Yantoro. Thank you for the opportunity to presenting our work. So I will be presenting our paper titled Towards a Human Values Dashboard for Software Development an exploratory study. So this is a joint work with Mojtaba Shahin, Waqar Hussain, Harsha Perera, Rifat Arashams from Office Lab Monash University, Michel Chaudron from Eindhoven University of Technology, and John Whittle from CS Aero Data 61. So I will start with what is human values. So in social sciences, human values are defined as what people hold important in life, such as privacy or universalism. So here we have one well-known model of human values called Schwartz's theory of basic values. So this theory divides human values into 10 categories and arranged them into a circular model. Some of these values are well known in software engineering, for example, privacy or security. However, the majority of the human values are still not known in software engineering yet. So human values are important in software because it is used as criteria for users to choose an application. For example, the recent Facebook privacy case reduced users' trust on Facebook significantly. So in a related case, a change of policy for data sharing with Facebook has made WhatsApp loses millions of users. So these events demonstrated the awareness of users about values and how they make decisions based on their values. Another example was demonstrated by several protests to racially biased facial recognition tools that increased the concern of discrimination against minorities. So to avoid this and to support the integration of human values in software development, previous studies have proposed several approaches. However, these approaches mostly not equipped with any tool to support software development. So to bridge this gap, we vision a tool called a human value dashboard that consists of two components, namely a backend and a front end. The backend will identify the presence of human values from software development artifacts. Then this information will be displayed using several views to software practitioners in the front end. At this point, because we do not know how this tool can be useful for software practitioners, we conducted an exploratory study to answer the following questions. First, what do practitioners think about values? Do they know what human values are? Do human values important to them? Second, if we provided a human value dashboard, we would get the benefits. Additionally, what are the benefits of a human value dashboard? Third, as we plan to use software development artifact as the source for identifying values, which artifacts are suitable sources for finding human values for the dashboard? And finally, what do software practitioners want in a human value dashboard to make it useful for them? So to communicate our idea to software practitioners, we developed a prototype that consists of 3 different views based on our examination of literature and our observation of existing dashboard for software development. We developed these views using static HTMLs. So in the first view, we developed a summarized view of the number of artifacts where a human value is identified. So in this view, we display 2 projects side by side to support comparison between projects. In the second views, we adopted issues displayed in GitHub, where we display value as a label on each issue where those values are identified. In the third views, we display issues where values are identified in chronological orders. Here, we want to explore if the emergence order of values during development could benefit software practitioners. Afterwards, we demonstrated and conducted semi-structured interviews that involved 15 participants with various roles in software development. And here are the results. First, regarding to the perspectives of the practitioner on human values, some values such as independence, achievement, and capable are not well understood by the practitioners. The practitioners seem to understand values that are well known in software engineering, such as privacy or security. The practitioners also believe that they have considered human values during software development. However, these values mostly are those who are well known to them. The practitioners also believe that some values are more important than others. These values can be influenced by the nature of the application. For example, if an application is made for elderly people, then accessibility is more important than others. However, some values such as privacy or security are always considered as important regardless the type of the applications. Second, regarding whom will benefit from a human value dashboard, the practitioners identify several roles such as project managers, requirements engineers, system analysts, developer, tester, and product owners in various software development phases. We also identified two types of benefits for the development team. The first one is to raise the awareness of human values in the software development team, shown by the green color in the table. And the second one is to determine priorities based on human values in the project, shown by the blue color in the table. For the artifacts suitable for finding human values for the dashboard, the practitioners identified several artifacts in various software development phases. Among those, requirement documents and issue discussion are considered as the most suitable where human values can possibly be found. The practitioners also suggested several points to make a human value dashboard useful for them. First, the detection of human values should be automated to save their time in manually labeling human values. Second, the dashboard should be traceable to the artifact source to make it easier for them to check the artifacts that they need. And then related to prioritization, the practitioner wants to be able to determine the value priority of a project and made the dashboard to display the artifact based on value priority that they define. The practitioners also want to keep updated when values are identified. And lastly, the human values dashboard should provide views to support various roles in software development. As a future work of this paper, currently we are developing the next version of the prototype, including development of a detection for human values automatically, and provide several views for various software development roles. So to conclude this presentation, there are two takeaways that I want to share with you. First, human values can be found in software development artifacts as suggested by the practitioners. Lastly, the practitioners see there will be benefits in the human value dashboard. Finally, thank you for the opportunity to presenting, and I will be happy to answer your questions. Thank you.
Thank you very much, Arif, for your nice presentation. There are questions from the audience. In the meanwhile that the question arrive, I have some curiosity regarding how you construct, develop, and your prototype. So you say that you analyze the existing literature and the existing dashboard that were available. Which was the criteria that you selected in order to prepare your prototype? And second, if the analysis of the literature was done systematic or not?
Yeah, for the examining of the literature, we didn't do it like systematically. So we just find previous work that discuss about dashboard for software development, and we try to figure out what is like how it be used and how it looks like. And then for the existing dashboard, we find several dashboards, especially for those who are connected to the repository, like GitHub or GitLab. Some of the dashboards are developed to like summarize the information from that repository. So we also have a look at that, how they display the information, and then we use that information to develop our prototype. Yeah.
Okay, thank you. And I have another question. Can you say which is the value more important? So it's possible to determine the most important value that was ranked, or there are some same trends for more than one value?
Yeah. So for software developers, software practitioners that involved in the fields, they also keep thinking that privacy and security are the most important.
Okay.
But they also realize that for some cases, for a specific cases, depending on the functionalities or target users of the application, some values are more important. So like I mentioned before, if the target of the users are people with disabilities or elderly people, then they also consider accessibility as well. So if it's, for example, also targeted for a special people from special area with some specific tradition, then they will also manage it somehow so that it can be accepted by those users as well. Yeah.
Okay. Thank you very much for answering to the question, and thanks again for your interesting talk and presentation. So we can provide the stage to the emerging results and vision paper that we have in this section, presented by Saima Sultana. The title is A Rubric to Identify Misogynics and Sexist Text from Software Developer Communication. The stage is yours, Saima.
Yeah, so can you hear me now?
Yes, we can hear you. Please go.
Okay, thank you. Hello, everyone. I'm Sama Sultana. Welcome to our presentation. A survey called Elephant in the Valley was conducted mostly among the women from Silicon Valley or Bay Area. 84% of the participants shared that they were called too aggressive in their workplaces. Also, 60% of them shared that they encountered unwanted sexual advances in their workplace. Harassment of women is not confined into only offline setting, it also exists in online communities. Online harassment of women first came into spotlight during the Gamergate controversy, which targeted women developers from video game industry. The harassment campaign included threats of revealing women's private information, threats of rape and death threats, etc. Apart from this, many jokes and memes are available in online communities, which questions about proficiency of women developers and express humor about their personal characteristics. Such incidents and jokes maintain the status quo and disrespect women. According to Oxford Dictionary, sexism is prejudice, stereotyping, or discrimination, typically against women on the basis of sex, and misogyny refers to the hatred against women. It includes harassing or threatening someone for defying gender norms. For example, while a sexist person can deny the fact that wage gap exists between men and women, a misogynistic person will believe that women don't deserve equal pay because they are inherently lesser than men. As these types of belief and speech creates an environment, intimidation, and insecurity for women, it hinders diversity and inclusion measures for them in workplaces or in social communities. Multiple studies have been conducted for automatic misogyny identification or AMI task, but they are based on Twitter data or YouTube comments. And there is no tool to identify misogynistic text for software engineering domain. Zhongling and his colleagues showed that existing sentiment analysis tools do not work well for the software engineering domain. Additionally, Sarkar and his colleagues showed that existing toxicity detector tools do not perform well for the dataset collected from the communication of software engineers. So, we aim to build a customized AMI tool for software engineering domain. For that purpose, we need a labeled dataset and machine learning models. But right now, we do not have any labeled dataset for this task. So we start with developing a rubric which will provide specifications about which texts from the communication of software developers fall under sexism or misogyny category. To develop the rubric, we need to collect existing studies about labeling sexist text. For this reason, we conducted a systematic literature review approach outlined by Kitchenham and Charters. We searched in Google Scholar, IEEE database, and Scopus using a fixed search string and found total 491 studies. After that, we removed all duplicates. This resulted into total 390 studies. Then we selected primary studies after going through title, abstract, and full text of the papers, where we ended up with 7 studies. We also found 3 additional studies through backward snowballing. We also followed forward snowballing, but we did not find any new paper here. So finally, we had 10 total primary studies that have some guideline about identifying sexist or misogynistic text or jokes. Our selected primary studies contain classification or misogynistic text or sexist jokes like the example given above. There were also definition of the particular subcategory that help us to identify any text or joke as misogynistic text or otherwise. We have aggregated all the distinct subcategories and developed our final rubric. We have found also 2 existing dataset of communications among software developers that contain sexist text. For each of the subcategory in our rubric, we presented one example collected from the existing data. If no example was found, we made an example by ourselves following the definition found in the paper. We have presented 2 examples here. Here is a sexist joke which falls into feminist backlash category. Like, why feminists hate Linux? Because they can't women command. So these jokes give a notion that feminists advocate for equalities regardless of gender, and when they can't do it for operating system, they don't like the system. Also, there is another example of misogynic text from sexual objectification subcategory. That is actually, I hope to see some sexy girls before the release. So here goes our final result. We have developed 3 different rubrics for identifying misogynistic text, sexist joke, and speech based on narration. So misogynistic texts are found to be of total 10 types. They can be derailing, stereotyping, discredit, dominance, and so on. Sexist jokes can be of total 8 types. They can express humor about women's personal characteristics, women's place in private sphere, violence against women, etc. Moreover, sexist speech are classified based on narration in 2 studies. They can be active, passive, or report. We have uploaded this classification in a GitHub repository. The link for the GitHub repository is given here. We want to maintain this repository, and based on the rubric, we want to label a dataset of communication among software developers and eventually build an AMI tool for this specific community. Feel free to reach to us for any query or questions. Thank you.
Thank you very much, Simon, for your nice presentation. There are questions from the audience. So in the meanwhile that the question will come, I have one question related to the methodology of the systematic literature review that you apply. Did you evaluate the quality of the paper that you at the end included, the 10 papers that you at the end have included? Did you apply the quality assessment criteria to check the quality of the data that at the end you extracted from this paper?
No, actually, we did not, until now, we did not check the quality assurance, but we'll do that before we start labeling our data.
Because it's one of the important step of the systematic literature review. And then regarding the future work that you highlighted in concluding your presentation, you talk about that you want to label using data sets, something like this. Do you have a specific requirements already determined about this data set? Are you looking for something in particular that maybe the audience can help you, since it's an emerging results?
So actually, we want to have some data set that is like real world communication data set from the software developers community, like any chat or like from where the developers regularly communicate.
Okay.
So, yeah, these types of data set, yeah, we are looking for.
Okay, thank you very much for your nice talk. So now, there is one question from Nick. And now I communicate also to you. We are the primary study in any kind of survey research case studies. What research method was more common in your set of 10 papers?
Okay.
Can you read? Are you able to read the question? Yeah.
Yeah, I can read the question. So those were actually few papers were actually an AMI competition, automatic messaging identification competition. So they were given a data set and they were supposed to identify those categories, like those categories using NLP models. So yeah, so they presented these like definitions and things. So most of the studies were basically in an NLP types of paper. So case studies, I'm not sure. I don't think there were any case studies. Yeah, but research method was more common. Yeah, they actually presented this definition and then they go on to like describing their NLP task. Yeah, so those types of work mainly.
Okay, thank you very much for answering also to this question. Thanks again for presenting your paper. And now, I don't know if the presenter that has a problem with the internet connection is still there with us, but we decided to show you to the audience to show the video, the pre-record video, so we can listen the presentation. So sorry again for the inconvenience, but in the video that we received, there is no the audio. So we can conclude, since the presenter is not here anymore, we can conclude this first section, and I wait you again with me as session chart for the third section of the day, that is on the fat prediction, that will be in 20 minutes, something like this. So see you later. Thank you very much.